Genique. Till now we have discussed the elements of static and time-varying electromagnetic fields, the uniform plane waves and the transmission lines and waveguides also, and we have encountered some of very important numericals so that you can develop your concept and as well as also how to solve the question for those type of questions. Okay, so now here the next topic is the antennas. Here from this from antennas we may get the questions either 1 mark or 2 mark questions every year. Okay, so the questions will be asked simple only if you know some of the concepts. So in these antennas we won't go the entire discussion here, then we will discuss only those parts, so we will get the questions in the examinations here. So today I want to discuss some of the antenna arrays here. Now, so before going to that, so what is meant by an antenna? So what is the work of this antenna? What is the need of this antenna in the electromagnetic field theory? See, what the antenna actually does means, so we know the uniform plane waves are generated because of the time varying current source. So because of the time varying current source, harmonic source, so the plane waves or EM waves will be generated and they will get propagated into the free space. And how this propagation takes place? So for propagating these waves, there must be a radiating element, and to get those waves, to collect those waves which are transmitted into the free space or any medium, there must be one capturing element. So the transmitting element and this receiving element is called as the antenna. So how this antenna is constructed means, suppose if you take, already we know, if you take any transmission line like this, for the transmission line we know how the transmission line, it is a time harmonic source. It is a time harmonic source consisting of voltages and currents VS, IS. Suppose if this transmission line is placed like this, it has kept open circuited. If it is open circuited means what happens? You know, there exists, because it is open circuited, it is a transmission line. Because it is a transmission line, if the transmission line is open circuited at the load or short circuited at the load, or if you connect any reactive element here, it may be reactive element means what? A purely inductive, a purely capacitive element here, then there exists maximum reflection. So the maximum reflection means there exists a standing wave on this line. So the voltage maxima and voltage minima and current maximas, current minimas will be existing on the line periodically. So we know on this we will get voltage maximas and voltage minimas. Here what about this? Here at the open circuit, what will be the current? At the load, the current will be minimum, because it is a load is open circuited. At the load, the current is 0. So that's why here you will get the current minima here and minima here, maxima, minima, maxima, minima. You will get the, just I have drawn it for current only, I of x something, mod I of x. Here also you will get the current standing wave. Similarly, you will get the voltage standing waves also. How the voltage standing waves? The voltage standing wave will be wherever there are voltage minimas, there exist wherever there are current minimas, there exist voltage maximas. Wherever there exist current maximas, there exist voltage minimas. So you will get the like this. So these are what? These are called as the current maximas, the voltage maximas. Here there exists a current minima. Here you will get a voltage maxima here. Voltage maxima, here you will get a current voltage minima like this. So this is called as V of x. So if you clearly observe this, wherever there exists a current minima, there exists voltage maxima. That's what. Wherever there exists voltage current maxima, there exists voltage minima. Like this. So it is just a transmission line, it is kept open. Now you should know that. So because of this, voltage and current waves are generated on the standing waves are generated on the line. And you should go to the basics that here there exists a current like this, a current like this. Okay. Now you should go to the basics that if there exists a voltage which is harmonic in nature, there exists the electric field because of that voltage. If there exists current on the current wave, there exists the magnetic field on this, around this line. So it is the origin of the EM wave. So how the EM waves are generated means, already we have seen in the waveguides and the uniform plane waves, but here because of this voltage and currents which is in the form of standing wave, the EM waves will be generated and these EM waves will be around this transmission line. But here, because these two are near to each other, the fields produced by this line and this line may get, the fields may get what? Cancelled. So to avoid this cancellation, what I will do that is, I have to do a small arrangement like this. Just I am opening up this, I am flaring this transmission line. So because of this flaring of this transmission line, then what happens? The fields also separated at a distance. Okay, the fields are also, these are what? Standing waves. These are the standing waves like this. So because of these fields, because of this flare transmission line, the fields may, there is no chance, there is the chances of cancelling the fields is reduced because of this flaring nature, because the distance between these fields will be increased. Now here what happens? So because of this, there exists, the field is radiated. So the field will be existing. That field is radiated into the medium. So this is the generation of this EM wave. The EM wave is launched into the free space. For getting the more the field into the free space, so we can further flare up this transmission line. So if you further flare up this transmission line, I will make this transmission line like this. Okay, so that I can get a more field, because of if it is kept like this, the cancellation of the fields maybe minimize it to 0. The cancellation of fields, minimize it to 0. So here you will get the maximum field like this. The maximum field will be radiated into the free space. So this is called as the antenna. The antenna is nothing but it's a transmission line. So here how the current is flowing? The current is flowing like this. Just it's like a two-port network. The current is flowing like this. So you can assume that the current is flowing like this. So there must be a time harmonic source to generate these EM waves, but to get the rays to be propagated into the free space, the antenna must be, the radiating element must be oriented like this. So then only you will get the maximum radiation into the space. So now what these antennas are doing, this is called as an antenna. This is called as an antenna, and there are different antenna structures are also there. Okay, generally we will see these kind of dipole antennas. So if you come to this, the antenna, these are the EM waves are propagated into the free space. Now what happens? So they are also, whatever the EM waves are generated into the free space are propagated into the free space, and they must be collected, and we have to get those waves. So for capturing these waves we need one more antenna, and that antenna is called as the receiving antenna. So that receiving antenna receives these EM waves and converts into the voltage and currents again. So first of what is these waves? Voltage and current. So finally at the receiving end they will collect these EM waves and it will convert it into VI waves, and this capture, the receiving antenna will capture these EM waves and it will convert these EM waves into the VI waves, so which is required for us. So like this total induction and radiation process takes place. So here if you take an EM wave, first of all VI wave, this VI wave is converted into an EM wave. Okay, so it is a conversion process. VI waves are converted into EM waves, and again EM waves are converted into VI waves. So this process of conversion of VI waves into EM waves is called as a radiation. Okay, and the process of conversion of EM waves into the VI waves is called as the induction. So because of these EM waves, the voltage and currents are induced on the line. So the entire process will take antenna. The entire process will be operated by this antenna. So it is a radiating element and also the receiving element also. This is the story behind these antennas. So for the gate point of view, here we will study the antenna arrays here. Okay, so here the most and well known the arrays here we will discuss. Okay, antenna arrays here. See why we are using these arrays. These arrays are used for to get the required parameters. So to get the more gain, okay, or to get the more directivity, and you will get these antenna arrays. So here for the simplicity I am taking a 2-element array here. So instead of taking an element array, okay, so I am taking a 2-element array here. Assume n is equals to 2 element with the currents equal magnitude, with equal currents. Right here it is with the equal currents, having a phase difference. having a phase difference alpha. Having a phase difference alpha. Now let us suppose we have taken two elements with equal currents having a phase difference alpha. You take two axes here like this. This is Z, this is Z, and this is X. Okay, let us suppose take like this. So observe this. Let us suppose this may be Y. If it is Y, and you can also take this one as Y if you follow the coordinates X, Y, Z. So now let us suppose I am placing two elements here. Okay, I am placing the two elements in the direction horizontally, and I am taking two elements like this. It is one element. So let us suppose this is it is excited by the current I naught into e power minus plus j alpha by 2. It is having a current I naught e power minus j alpha by 2. Okay, what is the phase difference? The equal magnitudes, and they are excited by the difference with the phase difference of alpha. It is having a current of this property. Now if you observe this, and these two are separated by a distance d. Let us suppose assume these two elements are separated by a distance d. Now we want to calculate the field point at this place. Okay, we want to calculate the radiation intensity or radiation density, anything at the far distance. So because of these two elements, I am placing horizontally like this and separated by a distance d. Now let us assume this is what? An EM wave propagating like this, an EM wave propagating in like this. Let us suppose this is distance separated by distance. See, the distance from the radiating element to the field point is r. If it is r, means what happens? What is the distance from here to there? It is, let us suppose, r1, because it is, if you observe this clearly, we can say that what? This r1 is having more when compared to r. So we know it is making an angle, this ray is making an angle with theta. It is making an angle theta with respect to z axis. Okay, so now one thing you have to know that is, because this point is far away from these two elements, when this distance is very much greater than this d, when this r is much greater than this d, what happens? When this r is much greater than d, now we can neglect this distance. You can neglect this distance. So if you neglect this distance, means these two waves can be assumed as a parallel lines. So that is the thing you have to notice. So as a distance wise, they may looking equal, but this path difference, the distance of this path will affect here in terms of phase. So it will generate a significant phase difference with respect to this one. The significant phase difference will be produced here in the field because of this path difference. That is the thing you have to notice. Even though the distances may be equal, but here you should notice that there is a phase difference which is produced at in the field produced at the far distance. So what is the phase difference? If it is theta, and it is also theta, always you have to measure the theta from the z axis. If it is theta, this is also theta, because okay, so this is the angle. What is this angle? The angle made by the line, this line, radius with respect to z axis. Okay. So this is the thing. So this is theta, theta. Now, so what is this distance? This distance is equal to, this distance is equals to d cos theta. This is d cos theta. So what is the path difference? The path difference is, the path difference is equals to, it is d cos theta. It is a distance. It is in general, it is in meters. It is in meters. Okay. Now, it is d cos theta. Now, what is the phase difference? So, what is the path difference in terms of, right? The path difference. Generally, we will represent the distances in terms of the lambda. In any transmission line system or also antenna systems, we will talk the path difference or a distance in terms of the path difference in wavelength. Suppose if I want to indicate or mention the path difference in terms of wavelength, path difference in terms of wavelength is equal to d cos theta divided by the lambda. D cos theta divided by lambda. So now this is the path difference. So because of this path difference, there exists a field, phase difference in this field. The phase difference due to this path difference is equals to 2 pi into the path difference. Okay, 2 pi into the path difference. So we know what? It is the phase constant. Okay, so phase difference is equals to what? 2 pi into path difference. This is the thing you have to notice. Okay, so what is the path difference? Here the path difference is equals to, so 2 pi. Okay, path difference is equals to, path difference in terms of lambda is equals to d cos theta divided by the lambda. So because of this path difference, we are getting the phase difference. How much phase difference? This is equals to 2 pi into that path difference. Okay. So this is the, it is equals to what? This is 2 pi by lambda. It is d cos theta. So this will be equals to beta d cos theta. So this is the phase difference due to the path difference. This is the phase difference due to path difference. Due to the path difference in the field produced at the faraway point. Now what is the total phase difference? The total phase difference is equals to the phase difference produced by the path difference and the phase difference produced by the current also. Already we have taken the currents having equal amplitude and phase difference of how much? Alpha. So the total phase difference, I am naming this total phase difference as psi is equals to alpha plus beta d cos theta. So this is the very important relation, and everywhere we will be using this total phase difference everywhere. So you have to notice this expression. The total phase difference produced in the E field is equal to, the total phase difference produced in the E field is equals to this one. Okay, alpha plus beta d cos theta. Now the total phase difference produced due to this one and this one must be equals to alpha. So that means, what is that electric field? We know the electric field produced at here is equals to E1 plus E2. Let us suppose this is element 1, okay, element 2. Let us suppose element 1 and element 2, what happens? So E1 plus E2. So because these are having an equal amount of currents, here also the field will be produced E0, equal amount of field intensities. But here, so because of this, what you will get? E power minus j psi by 2 plus E naught e power plus j psi by 2. Why I have taken? What is the phase difference between these two? This minus this phase minus this phase. How much? Psi. So the fields produced at the far distance having a phase difference of psi. So in such a way I am writing this. So because of these currents I am getting the corresponding field strength at a far away distance. So this is the total electric field. So here I can, if I rewrite this equation, then I can write this is 2 E naught cos of psi by 2. So this is the total electric field. So this is the total electric field. Okay. So now what is the maximum value from this E max? The maximum value is equals to, here is equals to 2 E naught. This is the maximum value. This is the maximum value. Here E divided by, I am writing here E max is equals to 2 E naught. So 2 E naught means what? This is called as, it is called as E max. This is called as the normalized E normalized. It is called as E normalized. And this is, sorry, E max divided by E divided by E max is equals to how much? This will, you will get what? This is cos psi by 2. So this E normalized is also called as array factor. It is called as the array factor. Because of this amplitude is 1, we can also say that it is a normalized array factor also. Okay? It is also called as the normalized array factor. And this is very important for proceeding next. Okay? This is called as the array factor. So now, so this is called as the normalized array factor. So now we got the array factor. Now the total radiation pattern. So from this I am drawing the radiation pattern. The total radiation pattern is equals to the unit pattern into the group pattern. Unit pattern into group pattern. Here the group pattern is indicated by this array factor. Okay. Here array factor, mod array factor. Here unit pattern is indicated by the cos theta. Here unit array factor is indicated by the cos theta. Okay. Why means, if you observe this, here let us suppose this is Z, it is theta. Here the radiation intensity at this place is dependent on this cos theta. Here this cos theta. Okay, so that is the thing. Here if you take this, the radiation intensity here E of theta comma pi is proportional to the cos theta here. Okay, it is proportional to the cos theta. So this is called as the unit pattern. Suppose if we take one element here. Okay, so like this. So this is unit pattern. It is called as the unit pattern. Here we have to write unit pattern cos theta into array factor. Okay. So what is this array factor? Array factor already we have find it. Okay. We have to note that what is unit pattern. Actually, if you take any current element, that current element is, suppose if you take any current element like this. Okay. At here we have to find the field pattern. The find, if let us suppose it is making an angle some theta here. Okay. Here the E of theta comma phi, the radiation intensity is proportional to the cos theta here, and you will get the field like this due to the dipole antenna or any Hertzian dipole antenna like this. Okay, so in that expression you will get this thing like this. So no need to, you have to remember this thing. Okay, this is called as the unit pattern. So now if you observe this, so this is cos theta into AF. So what is this cos theta? This cos theta is equals, so this is the total radiation pattern. So in this, if you take any binomial array, sorry, not binomial array, if you take any, let us suppose it is a broadside array. I am taking a broadside array. So up to here, the entire process is same for all type of the antenna arrays. All type of antenna arrays. So here, if I am taking a broadside array of length of elements 2, here I am taking n is equals to 2 here, and alpha is equals to 0 and d is equals to lambda by 2. So that means, what is the meaning of this? Broadside array means if you take the z-axis here, this is one element and this is another element, the distance between these two is, it is lambda by 2, d is equals to lambda by 2, okay, and it is also excited by an element I0, it is also excited by the element I0. So these two are given like this. In the previously, in the generalized case, I have taken I0 d power minus alpha by 2, here I0 d power plus alpha by 2, I have taken like this, but here this is the broadside array. Okay, this is the axis. Okay, so this is the antenna axis. This is the antenna axis. Okay, this is the antenna axis. Now I am taking the broadside array of two elements like this. Now this is called as the broadside arrangement. So it is same. Suppose if you use three elements here, one more element must be placed here. If you use four elements, one more element must be placed here. By having equal lengths from here to here, here to here, the spacing between the elements must be equal, and also the phase difference must be 0 for having a broadside arrangement. So from this, what is the psi here? Path difference. Due to this arrangement, the field point, at the field point, the phase difference here is, the total phase difference here it is 0 plus beta d cos theta. So this is equals to what? Beta is equals to 2 pi by lambda. We know d equals to what? Lambda by 2. Here it is cos theta. So from this lambda, this will be pi cos theta you will get. So this is psi. So this is psi. So this is the total phase shift, phase difference at the field point. The difference between this one and this one, the field due to this one and this one. Okay. Now we have seen the unit pattern. So what is the unit pattern here? So here the unit pattern, if I draw the unit pattern, how the unit pattern will be? The unit pattern here, this is the axis like this. Let us suppose take a unit circle. Here take a unit circle like this. Let us suppose this is z axis, we know this is z axis. Let us suppose this is some y axis, z axis. So we know this is representing what? Theta is equals to 0 degrees. This is theta equals to 0 degrees. Here what about this? It is theta is equals to 90 degrees, pi by 2. Here theta is equals to pi by 2. We follow that spherical coordinate system. So what about this? Here theta is equals to pi. Here theta is equals to minus pi by 2. Here theta equals to again 0. Okay. So if you observe this, in between what the value will be? This value will be, it is theta is equals to pi divided by 4, pi by 4. Here it will be 3 pi by 4. Here it will be minus 3 pi by 4. Here it will be minus pi by 4. If I taking this angle like this, or if I take the angle like this, because always the theta is measured in the clockwise direction. So that's why I am taking theta 0, pi by 4, pi by 2, 3 pi by 4, pi. It is over. And you can also write here one more pi by 4. You can also add. Instead of writing this, I am mentioning these angles like this. By taking the anti-clockwise direction, the thetas will be negative, because the theta is generally calculated from the top to bottom in clockwise direction. So this is the thing. Now you have to know this. Okay, always the theta direction is like this. Okay, this is the theta direction. Okay, theta increasing direction. Now here, if you put theta is equals to 0 degrees in the unit pattern, what is the unit pattern? Unit pattern is cos theta. If you put theta equals to 0 degrees, cos 0 is, here you will get a maximum value. Okay? If you take theta equals to pi by 4, the maximum value, the mod cos theta will be 1. Okay, like this. So here, what is the cos theta equals to pi by 4? Cos theta pi by 4. Cos pi by 4. Cos pi by 4 is 1 by root 2. That means it is less than, it is unit circle. This is unit circle. Now here, at this place, you will be having some value 1 by root 2. But at theta equals to pi by 2, what is this value? It is 0. Like this. So, if theta equals to minus pi by 4, it is like this. If theta equals to 3 pi by 4, it is also like this. At theta equals to pi, at theta equals to pi, what is this value? Theta equals to pi, it is 1. Cos pi 1. Magnitude, I am taking the magnitude. In this direction, it is 1. So here theta equals to minus 3 by 4, it is 1. So how can we draw this? So the pattern is like this. Here this is the pattern you are getting. So in the figure of 8 we are getting the unit pattern. So now it is multiplied with the group pattern, or it is multiplied with the array factor. So here what is the array factor? The array factor here is, now I am talking about the broadside array. Okay, we have to know what is the broadside array means. The phase difference between the two current elements must be, must be 0. Now come to the array factor. What is the array factor? Here the array factor is equals to what? Cos of psi by 2. So this is the cos of psi by 2. If you take mod, you have to take mod. This is the array factor. So cos psi by 2. So what is cos psi by 2? So if I want to write the cos psi by 2, okay. So this is cos of psi is mod. Psi is what? Already we got the psi is equals to pi cos theta. We obtained here. This is pi by 2 cos theta. Pi by 2 cos theta. Take the mod. So here what you will get? Cos pi by 2. Cos of pi by 2 into cos theta. This is the array factor. We proved this. Okay, psi equals to pi cos theta. Now, if I want to draw the array factor pattern, then how it would be? It will be like what? It will be like, now draw the unit circle like this. It is the unit circle. What happens if theta equals to 0 degrees? Already we know this is z axis. This is z axis. Okay, we know this is theta equals to 0. It is theta equals to pi by 2. Same, if theta equals to pi or minus pi, theta equals to minus pi by 2, like this. Okay, suppose if theta equals to 0 degrees, if I take theta equals to 0 degrees, cos 0 is 1 and cos of 1 into pi by 2 is pi by 2, cos of pi by 2 is 0. So cos of pi by 2 is 0. Here the pattern is 0 at theta equals to 0. Now if I take any mid value, if theta equals to in between, if I take any mid value which is convenient for me, if I take theta equals to some 60 degrees, if I take theta is equals to 60 degrees, what happens? Cos 60 is 1 by 2, 1 by 2 into pi by 2. So this will be pi by 4. So cos pi by 4 is what? 1 by root 2. So 1 by root 2 means in this direction, let us suppose some theta equals to 60 degrees. In theta equals to 60 degrees, this is the theta equals to 60 degrees. The amplitude is what? Some 1 by root 2. Let us suppose this value is 1 by root 2. At theta equals to pi by 2, what happens? Theta equals to pi by 2, this is cos pi by 2 is 0. 0 into pi by 2 is 0. So cos of 0 is 1. So it is having magnitude 1. Similarly, if you take theta equals to 120 degrees, you will be having the same magnitude. If theta equals to 120 degrees, you will be having 120 degrees means 90 plus pi by 3. Okay, so it is 90 plus pi by 3. Again you will be having the same angle. So here this is okay. So here you will get 1 by 2 again. Okay, so finally 1 by 2 into pi by 2. So you will get pi by 4. Similarly in this direction. So if you join this, you will get the pattern like this. Similarly, if you take these negative angles also, you will get the pattern like this. It is symmetrical about this. So this is about the array factor. Now, what is the total radiation pattern? Unit pattern into the group pattern. You have to notice the unit pattern is cos theta. If you don't know this, everything is waste. So if you multiply these two, the total radiation pattern will be like how it would be. The total radiation pattern will be like this. So if you observe this, what is this? It is the array factor. Here array factor is equals to 1. Here array factor is equals to 0. Okay, array factor is equals to 0. Here array factor is equals to 1. Here array factor is equals to 0. If you observe this, the array factor is 1. That means it is having array factor 1 means what? It is a maximum radiation. Here we are getting what? It is a null here. Okay, array factor 0 means in this direction you will get null. So if you observe this maximum radiation is, its maximum radiation due to this broadside arrangement. Due to this broadside arrangement is what you will get? Here you will get right angles to the what? Right angles to the array axis. What is the array? The antenna element is placed like this. What is the antenna element? I place the antenna element. Okay, this is called as the array axis. Okay, what is the, already I told, this is called as the array axis. Z axis is the array axis. Now, so because of this broadside arrangement, I am getting the This one like this. So that's why the maximum radiation is perpendicular to this. Now come to the total radiation pattern. So again we draw the same arrangement. Okay, again you draw the same unit circle here. You draw the same unit circle here. How we will get this? So for this same unit circle, okay, so this is Z axis, this is horizontal Y axis. Now this is theta equals to 0, theta equals to 90 degrees, theta pi by pi, it is theta equals to minus pi by 2. So here if you multiply these two, this one and this one, you will get the total radiation pattern. So if you multiply means, so this is the blue pen represents the unit pattern. So write the unit pattern here. So this is the unit pattern. The unit pattern in this direction. This is the unit pattern. Okay. Now what is the error factor? The error factor is the red pen. It is represented with in this direction, right? So this is the final radiation pattern of this broadside array of these two elements. Okay, so this is like this. So this is the final radiation pattern, the intersection of this one. Okay, so like this. So this is the final radiation pattern of this array. So now, so how to find these null points and the, what is this called? So this is the radiation pattern. Suppose if you want to find the half power beamwidth and anything, so where you will get the half power beamwidth? The half power beamwidth is where the magnetic, this is 1, okay, where this is 1, error factor is 1, okay, half power beamwidth and full first null beamwidth. Suppose if you take, if this is for maximum radiation, for maximum radiation, what it must be? AF must be 1. For maximum radiation, AF must be 1. So what is this AF? AF is called as cos of psi by 2. This is the AF, normalized error factor. So this is equals to what? 1. For having this 1, what it should be? Here psi by 2 must be is equals to cos psi by 2. 1 means what? Here it must be is equals to what? It must be is equals to zero. Understand? It is 0, comma, plus or minus, it is 2 pi. Okay, if cos psi by 2 is equals to 0, it is 1. and one more thing, plus or minus 2 pi, okay, sorry, pi, not 2 pi, cos, what is this error factor? This is error factor, okay, error factor is equal to 1, write the mod value here, okay, if it is mod value is equal to 1 means, what can I write? Mod value is equal to 1 means what? So cos of psi by 2 can take plus or minus 1. So from this psi by 2 is equals to what? If it is plus 1, what it will be? Psi of by 2 is equals to 0, and if it is minus 1 means it must be plus or minus pi, like this. So 0 for what? Plus 1, and plus or minus pi is for plus or minus pi is for what? Minus 1. So now, so from this, what is psi? So psi is equals to, what is psi means actually? Psi by 2. What is psi by 2? So psi by 2 is equals to what? So here also you can write psi is equals to 0. You can directly write. Okay. Here psi is equals to 0. That means you can also write psi is equals to 0 or comma psi is equals to what? Plus or minus 2 pi. But what is psi here? Psi already we have seen. Psi is pi cos theta is equals to 0. So cos theta is equals to 0. This is one thing. So cos theta is equals to 0 means what? Theta is equals to, it is pi by 2. This is one case. So at theta equals to pi by 2, what's happening? Psi is 0. Psi is 0 means what? Psi is 0 means what? If we put psi equals to 0, we are getting cos pi by 2 is equals to plus or minus 1. It is 1. It is 1. We are getting the maximum value. So this is called as the, it is theta max, theta m, right? Theta m. Okay. Now similar to this, if psi by 2, if psi is equals to pi cos theta is equals to plus or minus 2 pi, then what it will be? Cos theta is equals to plus or minus 2. So is there any condition like that? Cos theta is equals to plus or minus 2? No. So that's why what you can write? So you can remove this. It is invalid case. So theta equals to 0 means it may be what? Plus pi by 2 or minus pi by 2 possible. So theta may be plus or minus. The maximum points will be what? Plus or minus pi by 2. But here it is invalid. There is no such theta to becoming cos theta is equals to plus or minus 2. So I can remove this. These are the maximum, 5 maximum. Okay, radiation. For maximum radiation, error factor must be 1. For null points, these are called as what? Theta max points. These are called as theta max points. So now, so theta max points are represented with theta m. I am writing like this. So to find the null points, the error factor must be is equals to 1. So cos psi by 2 is equals to 1 here. So cos psi by 2 is 1 means what? Cos psi by 2 is 1 means so cos of psi by 2, sorry, cos psi by 2 1, not 1, it is 0, sorry, it is 0, it is 0, it is cos psi by 2 is equals to 0. So from this what can I write? So psi by 2 is equals to, it might be plus or minus pi by 2. Okay. So from this, what is psi is equals to? It will be equals to plus or minus pi. Okay. Plus or minus pi. This is one thing. And you can also write 3 pi by 2 also. Okay. For 3 pi by 2 also. So if it is, see, observe this, for psi by 2 is equals to 0 for plus or minus pi by 2, and there is one more condition is also plus or minus 3 pi by 2 or plus or minus 5 pi by 2, like that. Okay. So this is the thing. So from this, if you take psi by 2 is equals to plus or minus pi by 2, what happens? So psi is equals to plus or minus pi. This is one condition. If psi is equals to plus or minus 3 pi by 2. Okay. This is the thing. Now what is psi equals to actually? Psi is equals to pi into cos theta. Now write plus or minus pi here. Now cancel this. Here you will get cos theta equals to plus or minus 1. Cos theta equals to plus or minus 1 means what? It will be theta is equals to 0 for plus 1 and 0 plus for plus 1 and theta is equals to plus or minus 5 for minus 1. So this is one thing. So this is called as theta null. So this is represented with theta n. We got this point. Now what about this case? If I take psi by 2 is equals to this one. If I take psi by 2 equals to this one plus or minus 3 pi by 2, what happens? This one will get cancelled. So from this what is psi equals to again? This is pi cos theta is equals to plus or minus 3 pi. So pi will get cancelled. So cos theta is equals to plus or minus 3. So this is an invalid point. So this case will not exist. So these are the null points. These are the maximum points. So at this place you will get the maximum radiation. Okay. So this is about the radiation pattern. Now if you observe this, so if you take the array factor here, already we rubbed it, right? So if you take the array factor, how the array factor was? This was the array factor. Let us suppose this is the unit circle. Here the array factor is like this. This is the error factor. So this is AF is equals to 1. So that means here theta is equals to how much? AF equals to 1 for theta equals to plus or minus pi by 2. This is plus pi by 2. If theta is equals to minus pi by 2, we are getting the maximum values here. For theta equals to 0 and pi. For theta equals to 0 here and theta equals to plus or minus pi. So we are getting this is the error factor. So these are called as the null points. Okay. These are called as the null point. These are called as the maximum points. These are called as the maximum point. So here these are called as the null points. So now from here we will define the first null beam width. So these are called as the first null beam width. Okay, first null beam width is equals to the difference between the two null points. What is the difference between the two null points? It is theta. This is also null point, right? Null point in this direction there is no radiation. So here pi minus 0, it is pi. So it is 180 degrees is the first null beam width or full null beam width. So this is pi. Now how can we get the half power beam width? For finding half power beam width, the power should be half. For power should be half, this must be is equals to, for power should be half, this must be equals to 1 by root 2. So this square is equals to 1 by root 2. So array factor, this is for what? For half power beam width. For half power. For half power, this array factor must be equals to 1 by root 2. Okay. So this is the thing. So from this you have to find the points where you will get the theta values. So if you find the theta values here, so this is equivalent to what? cos of psi by 2 is equals to plus or minus 1 by root 2. So plus or minus 1 by root 2 means what? So psi by 2 is equals to, we can write plus 1 by root 2 is what? Plus pi by 4. Okay. And plus or minus pi by 4 you can simply write. So for plus or minus pi by 4 like this. So from this is psi is equals to what? Plus or minus pi by 2. It is plus or minus pi by 2. So psi equals to what? Already we know psi equals to pi cos of, for broadside array, pi cos theta is equals to psi. Okay. So phi cos theta is equals to plus or minus pi by 2. Okay. Here gets cancelled. Cos theta is equals to plus or minus 1 by 2. So here theta is equals to what? If we solve this, the theta will be equals to, the theta is equals to 60 degrees and minus 60 degrees. 60 degrees and 120 degrees. 60 degrees. Okay. And 120 degrees. Okay. So you cannot take minus 60. Minus 60 is what? This one. In this cos is positive. You cannot take minus 60. Plus 60 means first quadrant and 120 is second quadrant. In the 120, if you take 120, it will be minus 1 by 2. If it is 60, it will be 1 by 2. So now these two are called as the half power points, HBs. These two are called as the half power points. What is the half power point? So at this, you will get the error factor is 1 by root 2. Okay. Error factor is 1 by root 2. That is called as the half power point. If you square that, you will get 1 by 2. That is called as the power by 2. Okay, maximum by 2. So here at this place you will get, if it is 0 degrees and this would be 60. This would be 60. This is theta equals to 60 degrees. And theta equals to 120 means what? If it is 90 and this will be same. Theta equals to 120 degrees. Okay. So this is called as the half power beamwidth. Similarly, for these negative angles also, you will get the half power points here. These points are called as half power points. Theta HBs. So here you will get 1 by root 2. 1 by root 2. Here it is 1 by root 2. Because what? This maximum value is 1 unit circle. This is the unit circle. Okay. So now what is the half power beamwidth? Half power beamwidth is equals to the difference between these two. What is the difference between these two? 60 minus 120. This is 60 degrees. Okay. The difference between two half power points is called as so this is what? Half power beamwidth, HBW. I am writing this theta HPBW. So this is called as full null beamwidth. Okay, this is called as FNBW from here to here. So like this you have to follow. Okay. So this is the approach to find the radiation pattern and the first null beamwidth and the half power beamwidth. So like this. So in this you have to notice that is the unit pattern. Okay, unit pattern and the error factor. Okay, error factor are also called as the group factor. Okay, what will be the radiation if the group of combinations are taken? Similarly, this is I have designed for the n equals to 2 elements. Suppose if I take n is equals to some n elements, then the error factor will be changing. Okay, then the error factor will be changed. Okay, suppose if I take n is equals to some n elements, then the error factor for n elements what is error factor? Error factor is equals to sin n psi by 2 divided by n into sin psi by 2. This is called as the array factor. This is called as the array factor. Okay, and this is important also. Okay, suppose if you take n is equals to 2, what it will be? If you take n is equals to 2, why I have taken this one means, why only I have taken n equals to 2 means, to draw this kind of radiation pattern, so by using a numerical, you have to use some analysis type. So we cannot directly find the radiation pattern for n equals to some 3, 4, 5 elements. Okay, so that's why I didn't take this kind of radiation pattern to show an example. So only I have taken for n equals to 2. Okay, only for n equals to 2, because the representation of this radiation pattern becoming difficult to show this. But here if you solve the same analysis what you have done for the 2 elements, if you do the same analysis for the n elements, you will get the array factor n psi by 2 divided by this one. This is also called as the normalized unit factor, normalized array factor. Okay, the maximum value will be 1. So if you take n equals to 2 here, then what is the array factor? This is equals to sin, n is what? 2 psi by 2 divided by n means it is 2 sin psi by 2. So this is equals to 2 gets cancelled. If you observe this, sin psi, the sin psi can be written as 2 sin psi by 2 cos psi by 2 divided by 2 sin psi by 2. You can simplify this. So you will get what? It is cos of psi by 2, for which we got the already in the first. Okay. So this is for the array factor for the 2 element array. So for finding the array factor for n elements and showing onto the board is difficult. Okay. So for this we have to use some frequency analysis type. So we have to use some softwares to find this kind of radiation patterns. Okay. So like this. So high frequency, some softwares will be there, right? So those kind of softwares must be used to find that kind of radiation pattern. So this is the array factor. Okay. So this is how we have to solve. We have to see the first of all, for any kind of antenna array, you have to take the unit pattern and it should be multiplied by the array factor. The finding the array factor is this one. Okay. Okay. So I hope you got understand, and the same analysis is also done for the end fire array also. Okay. So you can go through that. So thank you.